Okay, so last time we met, we were discussing piecewise functions. I'm going to clean it up, tighten it up. So piecewise function is literally where you have pieces that collectively make a function. And we're looking at what I said, a linear piece and then something that's not linear. And all together, it's a function to remind us if we have any graph in the world, we can tell if the function probably in 5 seconds or less by saying, hey, it passes the vertical line test. So this is altogether a function, and in pieces, it's those parts. I had this example, I said, hey, we don't have its graph, but here's what it looks like. So like this right here is a piece, a rule, an equation if you want, that you use when your inputs are greater than or equal to 1. This piece is a different rule. And you use that piece when your inputs are less than or equal to 1. And then we left off by evaluating at 0. Since 0 is less than 1, we input it there. I'll just jump over here to 10. Since 10 is greater than or equal to 1, we use that. And at 1 itself, just pay attention to your inequalities. This one allows equality, this one does not. So we substitute in the 1 there. Okay, let's give this a little depth. I still don't like that. I can't get this to work consistently. We'll get there. All right, that's pretty good. All right, off we go. Okay, why did that just show up? Thank you, I don't want you here. This is an interesting looking graph. Give you a minute to copy it down and digest what we're looking at. While you're sketching it, I will tell you this is actually called a step function because it looks like a set of steps. It also perfectly fits a nice example of a piecewise function. There's some interesting parts of this graph though.
What kind of function did you say it was?
This is called a step function. First question. We were asked to use this graph to evaluate f of 2. What do we think we would say? 1. Correct. Because we're going to input 2. So 2 is our x value. So we look up to where the output is, which is right there. And on the y-axis, it's a 1. So, cool. Oh my gosh, stop acting up. The end of story. Part B. What about f of 1 then? If you get it wrong, you get it wrong. If you know it, you already know it. So who absolutely knows it? You would think. What do you say? It actually is undefined. So if you're saying 1, you're not super far off. You're not super far off. You're warm. Okay. So we'd look at 1 and we say, all right, it appears that there's a point there, but main idea, here's the thing you have to recognize. That's a hole. This is what we call a hole in the graph. We're going to see them later in this course as well. This is not a hole. We just say it's filled in. That's what it's not a hole. When you fill it in, it's not a hole. So it's filled in. It's closed is another thing we say. This is closed versus this is open. So if you see a hole in the graph, it represents not actually being an output. And since there is no closed point anywhere we look at 1, there's no output at all, we use the word undefined. So the point I'm trying to say is a hole in the graph this might not work with me tonight. I'm going to scroll back down in a minute. And that makes sense now for, if I go back to f of 2, this is why we said the output was 1 and not 2 over there. Because technically, it's not there. It's the hole. You just keep falling through it. All right, so that's what a hole is. Now, why? Why the heck did graphs have holes in them? Well, we'll see some examples, but the easiest thing I can do is still kind of just say, what if I asked us to do this? What's f of 1 and the tiniest bit past 1, like a super microscopic amount? 1 doesn't have an output, it's undefined. But if you just scoop past 1, does it have an output? The answer is yes. So that's a reason why we have holes in graphs, because we want to be really, 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 really close to 1, but for some reason, 1 is an issue. We'll see, we'll have some context to that in real world applications. But to me, this is a good example about why that works. So far, so good? Maybe, maybe not. D. We're going to write the functions rule. We use this 1/2 of like a big curly bracket just as to say, hey, we're grouping some rules. And I hope everyone sees that there is literally 3 pieces to this graph. The first piece is output 1 when your inputs are strictly greater than 1, less than or equal to 2. I'm going to ask you to do the next two parts. They're almost the same as this, so pay attention. This is the y coordinate rule. For these x values. I'll just say inputs, but it could be x values. Sorry for the lag. I'm going to figure out what's going on. It's literally just this classroom. I had no problem last night, no problem all day today in my other classroom. I don't know why here it's like lagging. I'll figure it out. Okay, so I'm going to emphasize one last time. The y coordinates here, there's nothing fancy about the rule here. It's like, bro, you're always 1. Every single point that's on this line segment has a y coordinate of 1. When your x values are strictly not equal to 1, because there's nothing at 1, but strictly greater than 1 and less than or equal to 2. So if you're feeling brave, take 60 seconds, write the next y rule and the restriction, and then the third y rule and the restriction. You have a minute to try on your own, and then maybe turn to a neighbor and say, hey, what's up? What'd you get? So final hint, you should have this piecewise function is going to have a second and a third rule, a second and a third restriction. Because there's 3 pieces. I don't see many people writing. A couple of us still are. So what's the second rule? The y rule is output
2.
when your x values are
Greater than 2 or less than or equal to 3.
perfect. And then 3 for x values strictly greater than 3, less than or equal to 4. Almost too simple, but it's, again, a nice elementary way to get started to really emphasize things we're going to be doing and how to read a piecewise function. We good? Got the vibe of that? I think it's time to switch it up.
We need to close the bracket for the other one, because we have the f of x.
You're asking about domain and range. I'll come back to that. So this is just an inequality. It's not like the bracket or parentheses. It's related to it. It's not the same thing. I promise am I answering it or no?
So we don't have to, you wouldn't write us.
Oh, you're asking this. My bad. No. Okay. My mind went a different way. No, this is just standard. It's only 1/2.
Are you sure?
I'll say this. It's really not a big deal if it's not. It's just a textbook's author's opinion. But I'm confident that our textbook, I'm going to triple check it. Why, do you think it's closed?
No.
Okay, it's all right. Oh, don't feel, I like these. There's, sir, I could talk forever.
It's similar to a polynomial, right? So in polynomial, you don't always close out the bracket, right? But this is setting up the rules you don't need to.
It's the conversation, by the way, that we're having right now is it really mathematical? It's technically not. I'll make the following analogy. You can have the most amazing thesis statement. It's like this most renowned opening thesis. You didn't capitalize the first letter. So it's really style versus like content. The content is here. If we freaking erase this, it would just be like weird looking, but the content's still there. It's there, right? It's definitely just one bracket. I will find it. I want to go back here. I know that for a fact. In our textbook.
Represents a set, right?
Yeah.
Is that what that is?
Well, if it's
Set.
closed, it's a set. It's really just grouping
All
it.
right. Now
Yeah.
it's-
Yeah, we're
Forget it.
I need to hear that.
so I'm asking you if you're like, what am I supposed to be doing right now? Give it another shot right here. Just make sure you got this. There's obviously every time I do something, there's a little bit a new flavor added to it.
You write the live, write the live access.
Do you want me to like this? Is that what you're asking?
No, just like the numbers, because we don't know what.
Oh yeah, that's true.
Might be that.
And then I'll say this is like 7. My bad. Yep, that's important. That's why I'm like, why is no one doing anything? Okay, I can show you our textbook. Uses one side. That's all. It's just grouping. All good. And I want you guys to feel comfortable about that. There's so cliche. There's no bad questions. Well, that's a lie. There are bad questions, but that wasn't a bad question. All right. So sometimes just the way symbols look can confuse us. I don't want to take away from the mathematics, which if you're recognizing there's 2 pieces, we need to write 2 pieces, and we need to write 2 what we call restrictions. You're getting the math part of it. So I don't think this is that interesting. 7 and 5, pretty simple. However, a little bit something on the restrictions here. What x values output 7? What's true about the x values? Strictly less than 5. Yes, it's for all x values strictly less than 5. When do we output 5? I'm sorry, when do we output? Oh my gosh, you guys are going to yell at me, aren't you? When do we output 2 for x values that are greater than or equal to 5? Super clear? So now, what's f of 5? The answer is obvious to me. If you use the rule, it says use this, output 2. If we didn't have the rule, let's go back to about 10 minutes ago, could we answer it graphically? Yes. Okay, one more. And then we'll,
So what was that?
oh, my bad, 2. What's the rule for this piecewise function? Kind of 2 new things here, but take a leap of faith. And if you're not sure, you don't have to put it in your notebook. If you want like a clean answer in your notebook, work your brain, spin the wheel. All right, it's way too quiet in here for me. So turn to a neighbor and discuss for a minute. What are you thinking? What's going on in your mind? Say hello. Hey, good day, all right. Discuss. What are you thinking? Turn behind, hello, say.
Just have a moment and then.
So,
Go
7 and 2.
right here, this
Not
one,
yet.
so, now it's somewhere big enough for this size. So it'd be much greater than.
So these extra coordinates are less than 5. So.
Oh, okay.
Oh, okay, okay. So, 7
Oh, you're saying from the 2. You're pointing here. Okay. I'm gonna walk away for that. Regroup, and then. This is just. Okay.
I always.
Oh, my bad.
This is the exact.
Also.
So what happened is, this is
Everywhere. Oh, yeah.
Yeah.
4. Greater
And then you go straight to.
Less than.
Yeah, I like that. So it's like-
You didn't have to write that down.
So like, so this whole thing.
Yeah.
Right.
And
It's
just, we're gonna.
Yeah, that's what I'm
trying. So. Less than. You have to write things just a little bit straight. So it helps check in with each other there. This is 100% correct. So in this area, I will look over here.
So the impulse is just like.
Here.
This was started too, though, right? Two of these years. Yeah.
So just kind of go through them.
And I went right.
So I'm doing it out of order, but
I have, this is a drawing.
this is and then we're saying here, whatever, so from 5 onwards, 5, and that's it, there's no other hand. I didn't get to this side of the room this time, I apologize, you were at my priority next time. All right, so this is why I like group work, or even just, no one likes to get started, but now the misconceptions, the conversations start. I'm one person, and you're feeling like, am I the only one who doesn't get this? And then you realize, no, I'm not the only one who doesn't get this. But there's gonna be like little spots, little pockets of knowledge. I'm one person, you are many people. And everyone's gonna get a pocket of knowledge at one point. So if you don't know something now, you will eventually become, like it's gonna click for you. So I know it's uncomfortable to talk to a neighbor, but try to get more comfortable with it. The more we do things like that, it just becomes comfortable. We're all learning. This is a judgment-free math zone. No one wants to take this class again. Everyone wants to pass. So let's help each other out. All right, moving forward. So some things that I like when I hear you guys talk that I can emphasize. So obviously this is a piece. We need a rule for that piece, and we needed restrictions for that piece. So the rule is the y coordinates. What's true about the y coordinates? They're literally not changing on that piece. The answer is they're 7. Now, when are they 7? Here's a way to think about it. This is an ordered pair, -8, 7. This is an ordered pair, -7, 7. This is an ordered pair, 0, 7. Everything on that line has a y value of 7, which is what we're saying, but there's a starting point on that line, -8. And there's an ending hole on that line, which is 5, 7. But I'll just emphasize, like I'm put a little asterisk because it's a hole, but it's kind of, the hole is at 5, 7. So when my x values are from -8 to 5, come on, let me write this and then I'm gonna clean it right up. That's almost perfect. If the endpoints are closed, that means we allow, oh my gosh. When the endpoint is closed, we allow it to be equal to. That's what allows you to close it. Anytime now. Anytime now. We have a second. Okay, that's rude. I'm going to let it go. We have a second piece. Not fighting you, bro. Right there. It always outputs 5. We can label this ordered pair. 5, 2. We can label this one and emphasize that it's a whole.
It's not 5, it's 2.
5, 2.
No, the y is 2.
I did it again, didn't I? This is no wonder we're having a hard time learning. The y is 2. The x is 5. This x coordinate is 6. This one here is 7. This one over here is 1,000,000. This one's 1,000,000,000, billion, trillion. So it's going on forever. There's no end. So all we need to do is say for 5 is less than x. Another way of saying the same thing, another way, you don't need both of these, but if you have this on your paper, you're saying the same thing. So I think in elementary school we learned the mouth is eating the bigger number. The mouth is eating the bigger number. You're saying the same thing. So either one of those, I'll just leave it like that. We don't use equality symbol here because it's a hole in the graph. Getting a little warmer with this? Because I'm going to move forward. Yeah, what's up?
Does the 7 have to be at the top or can the 2 be on the top?
The 2 could be on the top.
Okay.
Yep. As long as you have the correct, the 2 has to be with this condition. The 7 has to be with this condition. If you want to write it up there and there, that's fine.
Okay.
Uh-oh. We're going to need to review. So, telling you right now what's about to happen in 10 seconds. We are going to review y equals mx plus b.
Yay. Oh, those in this box are everything. The way you mean.
We are going to review slope, intercept, form, y equals mx plus b. How come? Because now things are, y coordinates are not staying 7 all the time. They're not staying 2 all the time. They're changing. So the rule for y is gonna vary. And we've all had algebra. Of course, we didn't have algebra, but there's probably cobwebs on that algebra. So as I said now, for the 3rd time, we need to review how to write the equation of a line. Who remembers what M is? Slope. Who remembers how to calculate slope? Perfect. It's a ratio. It's a fraction. Where we can say, if I'm at -2, comma 0, how much did I just rise? 3. It's easier with graph paper, but we still can just train our brain to do this. Let me help you. What's this distance? 2. So that's how I actually do this. I think where I'm at, get me to here, because that's easy. That's 2. And then how much more to here? How much more?
1.
So a total run of
3.
perfect. Rise 3. Run 3. That's a slope that simplifies to 1. While we're still reviewing, what's the formula? That's Rhode Island style. Formlar. Formula. And then words that end in an R, we don't use. We say ca. Spell ca. C-A. I'm going to go to the ca. There's an R there. No, there's not. Formula. There's no R. It's Rhode Island. Okay, I'll stop. What's a formula for slope given 2 points? Y2? There we go. So let's get the same answer. You don't have to do, we're done technically, but if this is too hard, I don't want to say too hard, like, I don't like that, then use this. So we have this ordered here, -2, 0. Let me change, let me emphasize the color here. So this is -2, 0. This point right here, even though it's a hole, it's the point where the hole is 1, 3. We could say y2, the second y coordinate is 3, minus the first y coordinate is 0. The second x coordinate is 1, minus the first x coordinate was a -2. And I'm probably one of the only teachers, professors who like literally doesn't try to hide that I'm subtracting a negative. I don't know why we make things small as teachers when we're like, yo, let's be clear, we're subtracting a negative to remind myself I'm ultimately going to add these. And if you're putting it in a calculator, cool, but just reminding us, keep change, change. 3 take away nothing, 2 plus 1. We would have got the same answer that way as well. So now you have 2 ways to have figured out the slope. What's B? The y-intercept. And it's not obvious on purpose. You could probably figure it out, but I'm going to go different with this. If I told us this, and we might guess and be correct what it is, but if I literally told you what it is, it'd be mad simple. But if you don't know to find B, sub in the slope. And over here, for X and Y, we're going to sub in a point that is definitely on the line. So I'm going to choose this one, -2, 0, because it's definitely on the line. So for X, sub in -2. For Y, sub in 0. 0 equals -2 plus b. We would add 2 to both sides and get the y-intercept. So I don't know if your guess was right or not. If you guessed 2 or you figured it out, good. But here's the algebra way to find the b value. Okay, so that's my review on y equals mx plus b. I'm not going to do much more. We're going to use it, but this isn't college algebra. We would spend more time doing that. That's a review. If you need more than that, tutor, YouTube, I'm going to post a link. It's on you. But that's that. Okay, now back to the pre-cal topic. Let's write this piecewise function. We have literally the linear piece, and the y's are not the same. They're changing. Already emphasized that. We just came up with a rule. It's mx plus b. M was 1. B was 2. For what x values do we use it? Well, here's definitely the ending x. And do I have a starting one? Nope. Nope. So there's no starting x. So this is for x that are less than 1. Let's just double check that. Sub in the number -2. Let's just double check that. Sub in the number -2, which is less than 1. So we would use this rule. 1 times -2 plus 2, output 0, as it should. The other part of this graph, y's are not changing. They're always 3. Yep, thank you. I'm gonna bring in candy. Not for you, for me. I obviously need candy and sugar. Right? That's what it is. It's lacking. All kidding aside, math team sure. Sorry, I probably should this off, but we had a competition today and they did extremely well. So I'm actually amped up. Yeah, it was awesome. Like the highest score ever. Side note to my students, like a perfect score for like a student is 18. And I've had one student this year get it twice. That's like in all my years coaching, I was like, sweet. And he's the top senior in the state right now. I was like, oh my God. This meet, he got 17 and he lost a 1-point question, which is just silly. If you knew it, it'd be like, and he's so upset. But it's not, it's really not. But 2 other students got an 18. And I was like, oh my gosh, so good for them. So I'm actually amped up. All right, so this is for the y rule is always 6. There's no change. So that's that. For x greater than or equal to 1. So far, so good. I'm going to really step back now. Write the piecewise function for this. We're coming coming to a close. You can do this one, I'm feeling pretty good. If you need some hints, look back at the example we just did. This is y equals mx plus b because it's a line. This is y equals mx plus b because it's a line. So, one problem at a time. First, find the slope, however you want to. Find the y-intercept. It probably is a gross looking number. Calculators are okay. Leave it as a fraction. Practice using your calculator.
Oh, no, just kidding.
Then you have another line with 2 points on it. Find its slope, find its y-intercept. Lastly, clean it all up into your piecewise function. I'm not going to let you look at my work. You are going to get fractions. Just it will give us some confidence. Is anyone getting negative 45/8 at some point?
Oh, we're not supposed to.
I did.
Oh, okay. I was like, why just-
It's not any final answer. At some point you work negative 45/8. I'll get there in 1 second.
But the last one was 1x
Oops.
plus 2.
I'm gonna attack this, which is a line, y2 minus y1, x2 minus x1. Makes negative 9/8. That's slope. Take your slope. Substitute it in right here. And choose a point on the line. I went with 5, -1. Maybe you didn't get negative 45/8 because you used a different point. But I did. You don't have to use either one. I used my calculator. It made that. And now I'm just using my brain to say I need to add this ugliness to both sides. And it's a good opportunity, since it's week 2, to say, if you don't have a calculator, I would not put this on a test or a quiz, this ugly fraction. But it doesn't mean we won't see classwork examples or my lab practice. So I would recommend that you get a calculator, specifically one that I recommended here, because it's so easy. -1 plus, there's a fraction button. And a lot of your calculators have fractions. I'm happy to look at it for you after class. -1 plus 45/8. And just like that. You don't have to do any stress. You just have to do the algebra steps. So 37/8 is the B value. M equals, I'm going to attack this line segment now, y2 minus y1, 4 minus 2, x2 minus x1. 2 on top of 1 simplifies to 2. That's fair game for tests. Because I already said, you should be able to take my assessments without a calculator. You can have one, but I wouldn't put anything like on that. There will be time fractions that are going to come up. We're doing trig. Trig is a study of ratios. Everything's a fraction. So m equals 2. Y equals mx plus b. Sub in a point on the line. I'm going to choose 6, 4. Subtracting 12 makes -8 for b. The function is negative 9/8 x plus 37/8 for x less than 5. The other piece, 2x minus 8 for x greater than 5. Let me look back at my graph and recognize I'm missing one element over here. This is closed. So I want to include 5 on that portion of it. Zooming back and looking at the big picture. And just a reminder, this is being recorded, so you can access this part of the video. If you didn't see the message that I emailed, on our Blackboard where you get My Lab, there's a folder that says weekly content, and the videos we posted there after class. Time I go home and do it. I'll back to this part. Here we go. Okay, so what might be intimidating to some of us, because it's really quiet and I'm getting the vibe, shouldn't be the content. We need this part, this part, and the restrictions. You just might be intimidated by some fractions. Okay, it's pre-calc. They're going to happen once in a while. But it's a slope formula, it's algebra. It's a slope formula, it's algebra. Find M, find B, and put it all together. You said you had a question. I went through it. Was it clarified or not clarified?
Clarify.
Cool. Anything else lingering, burning, wondering? All right. So we're going to look at two applications. First, you earn, I think it'd be pretty good if you're making 20 bucks an hour. So, and it's a nice number to work with, and it's reasonable. If you're not earning 20, but pretend you earn 20. Someone's earning 20 per hour. After 40 hours, what happens? Well, in today's day and age, you're lucky to get 40 hours. But if you can get a job that pays overtime, you get paid 30. This is called time and a half. You get your time per hour plus half of it. So half of 20 is 10. You get 20 plus 10 more. Write a piecewise function that outputs your earnings if you work H hours. We're not using X for our input. We're using H. That's the only real difference so far. There's a few differences, but like one thing we're going to do is not write X. We're just using H. It's our input variable. And I'll use E instead of F. What do you think E stands for? Cool. So part of this course, when we look at some applications, is we're not always going to use F of X. Just remind us of something I said last week. This does not mean E times H. This is a name. This is called the earning function, the earning rule. And our input is not X. Instead, it's H for hours. So your earnings of hours I did this last night with the pre-calc class down the hallway. Nobody got it right, and everyone loved this question. They're like, that's kind of cool. So let's try it here. Try something. 5 minutes. Really do it. I'll give you the answer in a few minutes. We're not leaving without it. But problem solving is figuring out what to do when you don't know what to do. And if I told you what to do, that's no longer problem solving. That's answer giving. So I'll guide some hints though. Well, come up with some concrete numbers. Maybe sketch a graph. Nothing crazy, just sketch a graph. So what happens if you work no hours? What happens if you work 1 hour? What happens if you work 20 hours, 40 hours, 100 hours? What's going on here? My second hint is there's two pieces. One is going to be easier than another. If you're making $40 per hour, that's a pretty simple rule to write. The challenge here is calculating your overtime hours. So, yeah, let's go 5 minutes. If you need to use the restroom or grab a little fresh air, don't make it super long. But if you just need to clear your head for a minute, regroup, we'll come back, answer this, and kind of wrap up, as I said, the main points of the past few lessons. Ooh, sketchy.
Can get my girl
Yeah.
before I go.
This one right here. So the way I'm interpreting it is if I work 10 hours, how much am I going to get paid?
20.
So 20 an hour, but I'm not asking how much per hour I'm getting, I want to know how much money my paycheck's going to be.
It's the worst.
This is asking me, let me rephrase this. I want
Yeah.
earnings of zero. How much should my paycheck be? Sadly, but that's the truth. No work, no money. I work 5 hours. What's the output? Not 20, but 20 per hour, so 100. I'm not looking for an answer. I'm looking for you to think about it. These are kind of my hints. This is almost not a hint. This is all behaving the same way. So how is it behaving? It's not always, it's changing. But this part is all behaving the same way. It's 20 per hour. And then it's interesting. What rule do you input 41 to get your output? And literally guess, check, try something is better than doing nothing. If you never try, I'm gonna tell you what is gonna happen. I hate math, I suck at math, I never got better. You're in a mindset, which is called a fixed mindset. It's like you're just not willing to fail. Like have fun with it. I said last night, the class left like laughing, not one person got it right. So are some of us sketching graph, which is a great place to start when you don't know what to do. Or creating a table of values, doing something. Maybe because I said graph, you went that way. So $0, 0 money. I'm sorry, $0, $0. 1 hour, 20, 2, 40, 360. And you should have this vibe that it's going up at the same amount. It's going up 20 per hour. And the y-intercept is 0. It's the amount you make if you do no hours. So really simply, m is 20 over 1, 20 times h. And I think some of us are like, yo, you're overcomplicating it. Yeah, I almost am. But I saw a lot of people didn't even do anything. $20 per hour. You're going into the real world. You're getting 20 times h. That's it. The first part of this was super simple. You didn't even need a graph. 20h. What's the restriction? You can work 0. You can work 40. You can work anything in between 0 and 40.
You can't work negative hours.
That's why it has to be greater than or equal to 0. But you work negative hours, I owe money? That's strange. Yeah, so it doesn't even make sense in this context. Okay, so we need a new rule for h greater than 40. Anyone have something? 30h. That was an answer last night. So obviously wrong. This is wrong. Why is it wrong? And it's all good. Don't take it personal. We're having fun with it. But it's the number one answer I got last time. Yeah. 100% better. The easiest way I can suggest or show why this is wrong is, let's hypothetically say we're working 41 hours. Does 41 fit here? Nope. So we'd use this rule. What? Oh, so you're getting paid. So what's wrong with this is, this would be like, if you work 41 hours, we're going to pay you time and a half for all your hours. Bro, that would be sick. I would definitely work overtime. But if you see it, it's not correct. See, we're starting to smile. We're going to have fun with this. That would be awesome. But it's not true. It is the first incorrect answer that came up last night. We can have fun with making mistakes, but we also want to learn from it. Okay, we need to revise this, but there's definitely a 30. There's definitely a 30 times the amount of hours you work, but it's not all the hours. Your hand was up next. What's your name again? I'm going to start asking. I can obviously call attendance, but I need to put name with faces. Alex, what do you think?
I don't have an answer, but I added to my graph by making the net segment go up at a steeper angle.
It went up at a steeper angle. So you turn to a graph, not to scale. What happened at 41? Did you calculate an output there or no? Okay, you just have a shape. He's like, all right, now I'm thinking it's got to go steeper, to get more money. So there's definitely a change. Cool. Next hand, yeah.
30 times h minus 40.
H minus 40. So I'm going to say sayonara, 30 times H minus 40. Exactly the same answer we got last night. And we're one step warmer, but still wrong. But let's see why. I love it. This is getting us to the answer. Let's sub in 41. So we already made right here. Sub in 41. Take away 40. Cool. We're getting warmer because now 1 hour is calculated at 30. Bro, what's the output as is? FE of 41 is $30. I just worked 41 hours and I'm making $30 on my paycheck. That's completely opposite of getting paid 7.5 all the time, but we're warmer. Okay.
Would you not just find what you would make if you worked 40 hours? So like, I think, what, like 1,500, I might be so wrong on that.
No, you are. No, you're not so wrong. No, I didn't. You're so right, actually.
Yeah, so it would be 800, so wrong, but 800, so it would be 30H plus 800, but I don't know if the H is right, because like, H is different in this case, like it's not, or, no, it's not. Because it wouldn't be your total hours, it would be whatever your overtime hours are.
I'll tell you this. No one said this last night. This is the correct answer.
Including the H minus 40?
Yeah.
Okay, all right, that's
and-
Oh, because you're overtime.
It's starting out at 40 hours.
And now it was like, oh, I almost see it. If you see it, it makes complete sense. It's almost mind changing. Like, and you're like, wow, math functions can be interesting in a way. Like we can leave it, my math team, we're wicked nerds. We have lives, but when we're in a math team, we have fun with it. And when you see it structured like this, and I hope everyone has that moment, and some of us are starting to now. We're gonna have a lot of moments in this class. But we had some fun with that. Okay, what's up? And then I'm gonna tie this all, clean it up. We're gonna do a nice clean example.
Is the 800 coming from 20 times 40?
So the question, I know the answer, I'm gonna pass back to your classmate. Is the 800 coming from the 20 times 40?
Yeah.
Yes. So the idea is this. First, I'll explain it, but let's just kind of do what I've been doing. So I work 39 hours. It makes sense. You're getting paid 39 hours at 20. You would multiply that all together. You work 40 hours. It makes sense. Now we go to 41 and watch the structure of this. We sub in 41. You take away the 40. So it becomes 1 hour at $30. So you have your overtime pay 30, and we're gonna add your already, like it's your 40 hours at 20. 40 times 20 is 800. So it's like you're getting your regular check plus your overtime pay. 42 hours, same idea. Substituting 42, take away the 40, now you're getting 2 overtime hours at 30, so that's 60, plus your regular paycheck of 800. And now this is working exactly as we would hope. Very, very cool. Very, very cool. All right, so nice and clean. E of H is 20H. Another cool conversation that came up is you can't be negative hours, but it is okay to be 0 hours. You can work half hours, you can work 6.5 hours, whatever. Maybe you go home, whatever. After that, so greater than 40, you get 30, but not for all the hours, for the amount over 40. So we have to subtract off the 40, but add your original rate of pay. And you already got that. New example. You sign a contract. Watch how fast they do this now. I think, let's see if you got it. You sign a new contract, you sign a contract that says you make $50 an hour up to 20 hours. You will get double time for hours over 20. Write a function, E of H, that gives your earnings. I'll still put a little flair on it, but not a lot.
What's 50 per hour?
50 per hour, up to 20 hours. You work more than 20, you're gonna get double pay.
So $50.
50 per hour. 50 per hour. I hope you get that and more. That is, well, this part, you definitely that, and then this would be pretty sweet. But I hope you get that and more. I really do. I hope I get that and more. Then I won't need this. But I like doing this. I really like. What's that phrase? You find something you like, you never work a day. I feel like I work double day. No, I just kidding. I work. Okay, I don't want to take too much more time. If you're still thinking, great. But this now, the problem solving almost feels stripped, and that's cool too, because that's also part of problem solving. You refer back to previous examples you've seen before, and either say, "Oh, I've done something like this before. I can regurgitate it. I can come right back up with it," or it's got a minor twist. So there's a few twists here. I said double, not time and a half, and I changed the 40, just to a hypothetical. But now you're saying, all right, common sense. I'm getting 50 per hour. Why am I doing that? I did that twice. For 0, less than or equal to h, less than or equal to 20. So there's one little change, but cool, you're paying attention to the details. Now you're getting double pay. So you're getting 100. Someone help me out. Do I need grouping symbols?
Yeah.
100%. I'm not going to write grouping symbols and show you why that would be wrong. So now if you go to substitute in a number, order of operations would say, like say 21. It would say 21 times 100, then take away 20. No, you need the grouping symbols. And then plus 1,000. Yeah, that's pretty sweet. And where did that come from? That's 20 hours that you work at 50, which would be $1,000. Yeah, that's a pretty sweet deal. I want that job. So remember who taught you how to calculate this? Oh, and by the way, it's for H strictly greater than 20. I'm going to stop our lesson on piecewise functions there. What took place there? A few things. First was I introduced it at the start of last class. I was just evaluating it. So you can evaluate it by just plugging in numbers using the restrictions. The main part of today was still doing that, but also bringing back to life y equals mx plus b. And I get it. I felt the vibe. I can feel it when it's like uncomfortable because fractions come up and everyone's like, ah. So if you don't have a calculator, get one. Also know I would never put something that nasty on a test, but it does not mean we won't see some, if not more, fractions throughout the course. So get used to it. As politely as I can say that. And then lastly, an application or two, I mean, it was pretty much the same thing, about how these can be used. There's other ones, but I think this is the most enjoyable one because it does kind of, one, give everyone a moment of appreciation, be like, oh, that was actually interesting to structure it that way. Am I going to use this in the real world? I don't know. Maybe, maybe not, probably not, but it's still a connection to things, how some paychecks work. What's up?
When it says 0 is less than or equal to h,
Mhm.
wouldn't we just have that as not equal to, because the 0, you're not making any money at 0.
Can I input 0? Is it possible to work 0 hours?
Okay.
So since 0 is in the domain, we need to pair that with something.
Okay.
We want to pair it with $0.
Okay.
Now, another conversation is -1 in the domain? Does it even make sense to talk about, well, I work -1 hours? No, that's impossible. You can start working 0 hours. That's where we're going to start, which would output 0 paycheck. Cool beans. Okay, I'm going to switch to the document for a minute. I printed out the homework, the one that started a week ago, which most of you already got 100, so I'm not going to spend a lot of time on this one. I'm just going to look at the questions together with you. At this point, you have a set of ordered pairs. This seems mad simple. The x coordinates are domain, y coordinates are range. These are isolated points. They're not connected. It's just like point, point, point. So you scoop up the X's, you scoop up the Y's, don't write repeats, order doesn't matter. Is something a function? If you have a repeated X, so I have a repeated 3, most likely it's not a function. Just double check that these are different, then it's not a function. I said in the directions, again, I don't want to spend a lot of time because most of you did this. It should have been a little pop-up. It says this is a function. It should have said in structured tip because I added that in. Use Desmos. Okay, there's a way of doing it without Desmos. I didn't want you to do that. I wanted you to use Desmos to see how do you I think most of us used it, but there's a cool opportunity to use a graphing calculator and just look at the vertical line test. If it passes the vertical line test, function. If not, no. Evaluating functions. One thing, you can input numbers, but we can also input expressions. So -4 goes there. 77 goes there. And then you just literally write X minus 4 right there. Clean up what you can. Use the view and example as needed to just see when you need to. Off you go. More evaluating. You should know what x-intercepts are from previous courses. Even if I don't 100% say something, it's something that I think is you should know how from a previous course. And that was pretty much that little section of that homework. I'm going longer than I really wanted to here. There was some piecewise. So even though I went through it tonight, I signed it last week, didn't get to it. But if you finished it, you're cool. Now we can look at this. So another goal is just evaluating a piecewise. This is the restrictions. This is the rule to follow. This is literally just plugging in numbers. Let me kind of use this one as an example. Monday, I showed you graphs that are constant versus increasing, which is just common sense going up, but they can also curve upwards. So hopefully you have those notes. It's in the video if you missed it. And then you can have decreasing or curve downwards. So where is this increasing? Nowhere. There's nowhere if I was a ladybug that I ever feel like I'd be going up in life. Where is it decreasing? Right here. So you'd say from 2 to infinity. Where is it constant? That's the no change in y. -infinity to 2. In all of this, interval, domain intervals, increasing intervals, is interval notation. I posted a video for the organic chemistry tutors. That video is really well done. Some of you already said after class that was helpful. Students in my other class said the same thing. So I'm not officially going over it. I did briefly. We've been using it. If you still need more and you haven't checked out the video, that's on you. Okay. Doesn't mean not to reach out to me, but you're expected to spend 2 hours per every hour in class reviewing and studying. So that's the CCRI standard, right? But if you already know it, I'm not forcing you to go. But this class is going to take some work here and there, is what I'm trying to say directly. Back to the main points, increasing, decreasing intervals. There's something about even and odd. Some of you answered them. I'm going to say right now, you can skip them, and I'm going to just give you the 100 up to that point. If you already answered them, cool. I haven't formally defined it, and I just don't want to right now. I have another place to do that in the semester. The homework from, was that both of them? The homework that I assigned after Monday's class, and I already apologize, some of them are repeats, but if it's a second time through, should be able to go through it pretty quickly. A lot of those are just making sure you can find domain and range, intercepts, and evaluate the function. By the way, just to remind you, how do you evaluate if you don't have a rule, but just a graph? This says go to x is -3, 1, 2, 3, and take the y coordinate. In this case, it would be 0. I apologize for the repeat there. I also talk about factoring as an algebra skill. So if you didn't do the homework, some of us are going to have to go back And I didn't do a lot of it tonight, but I know what's coming up hardcore in this course. So even though it didn't really fit in per se in a lot of what we did, it's coming and it doesn't go away. So I want us to be ready for it. Factoring trinomials, split the middle method. I did a couple examples. I posted a YouTube video. That's like 4 minutes, exactly how I do it. She's direct, clear, explains it. It's the algorithm to follow. Tonight, I already said we talked about piecewise kind of writing. Y equals mx plus b, and that application. There'll be a short couple more questions just based on like mx plus b stuff. Not a lot. Please have all 3 assignments completed and have a good foundation of functions, domain, interval notation, and factoring. We're moving forward. We use that, but we're getting out of this like conversation now on Monday. See you then. By participating, I took attendance and yeah. So not every single day is going to be like turn to a neighbor for 10, 15 minutes. Some days are just like today was just participate along. Smile a little bit, take some risk a little bit, ask a lot of questions. Let me pick on you a little bit and say that was a bad question when it really wasn't, but just meant to make you laugh.
When we're all like creepy smiling at you.
Yeah.
Down, don't
Yeah,
know
it's all
why.
good.
I walked in a couple minutes late again.
Okay.
Make sure you have me on attendance.
You're good. See you later.
I don't know why everybody gets fractions.
Yeah, I don't know either. Actually, they're so, no. And if you found a little enjoyment with that, we'll see sometimes they're like, wow, the fractions, they have a bad stigma attached to them, but they're really nice objects. I'm glad you already appreciate that. Have a nice weekend.